On June 4th, 2015, GOES 14 was placed in Super Rapid Scan Operations for GOES-R, or SRSOR mode, meaning that 1-minute imagery was being collected to emulate what will be more routinely available when GOES-R comes along. Let's go ahead and focus in on Wyoming and Colorado. So on this particular day, there was quite a bit of CAPE available from the Front Range extending up into southeast Wyoming, and there was also quite a bit of a cap in place. So storms initially only got going along regions of higher terrain. So during this loop period, which runs from 1754 to 1951 UTC, you can see the storms got going along the Palmer Divide, the Cheyenne Ridge, and then further north there was less of a cap. So along this boundary between the unstable cloud streets and the stable wave clouds north of it, we also saw a storm get going further to the north. Now notice that along the Front Range and much of the Laramie Mountains, the convection was struggling more because of that capping inversion that was still in place here. So if we look further to the east in northeastern Colorado, you can see this cumulus field with an embedded area of agitated cumulus in this vicinity, and this would definitely be monitored for possible convective initiation a little bit further in the future. Also notice that it's gradually working its way towards the west. Let's go to the next time period, which picks up where we left off and goes through 2134 UTC. So we go ahead and zoom in, and we see that storm to the north that initiated along that boundary that we mentioned earlier seems to be backbuilding towards the southwest as we get to the later portion of the loop, and that trend is consistent with a wind profile that shows strong flow at and above 500 millibars, but there was a weakness in the flow between 700 to 550 millibars. Meanwhile, further to the south along the Palmer Divide, you can see the initial storm weakened, and then we get a number of new storms that developed shortly thereafter just west of that. Meanwhile, to the northeast of that, we see a storm actually did go within this agitated cumulus field further to the northeast. However, it's not as robust as the convection further to the west, so it may be fighting more sin here further to the northeast. Notice along the Front Range of Colorado that we still don't have convection. That's still fighting that capping inversion that's in place. However, notice that cumulus field that we had been tracking along this line approximately is moving slowly to the west, which may play a role later. Meanwhile, we have this storm near Cheyenne, Wyoming, right here, and you can see some interesting storm scale features with this. You can see a flanking line on the southwestern flank of the storm, and on the southern flank of the storm, during particular times you can see a cloud deck that's lower than the anvil cirrus appear at certain times. And we're going to go ahead and look at that in a little more detail on the next slide. This is a time-matched composite series of images with the 1-minute visible satellite imagery in the upper left over the storm of interest, the radar reflectivity from the Cheyenne radar in the lower left looking at the storm just to the northwest of the radar, and in the upper right we have a time-lapse video taken from this location, pretty close to the radar, so we're looking towards the northwest. Looking at the looping imagery here, we can see the main updraft base associated with that storm. You can see variations or pulses in the updraft base on the southwestern flank of the storm. Over here on the right, you can see the inflow feeder band, which is just east-northeast of the storm. And we're going to go ahead and zoom in just the 1-minute imagery here. Speed up the loop, rock it back and forth. And you can see, here's the flanking line. You can see the overshooting top right here with the anvil cirrus streaking out towards the east. And one of the interesting things that you can see on the southern flank of this storm, generally in this region, are these mid-level stratus clouds that kind of come and go in terms of seeing them in the imagery and then going away. These are likely associated with a gravity wave emanating away from the thunderstorm. If you look very carefully, you can see the gravity wave emulating towards the south in the line that I just drew in. So go ahead and focus your attention on that. Go back and forth in the imagery. You can see it right here. And I'll go back and forth. And what happens is as that gravity wave moves through, you can see a change occurring here in the cloud field underneath it. So at certain times here where we have the gravity wave associated with upward motion and condensation occurring, you'll see these mid-level stratus developing, and then they go away, likely we're on the downside of or the subsidence side of the gravity wave. So we see these changes occurring associated with the gravity wave. Let's go back to our composite imagery here and see how these gravity waves appear in the video over here on the upper right. What I'm going to do is stop it at a certain time and note this region in here. Initially it's mostly free of these mid-level clouds, and then as I go back and forth you can see the development of these mid-level clouds. So these are some of the mid-level stratus that we were analyzing in the 1 minute imagery on the upper left. If we go ahead and look at it, how it looks in that particular time. So here's the development of these clouds on the right. These are the clouds that we're looking at in the imagery where I'm pointing. So let's go ahead and look at some other trends with this storm. Note in the lower left we have the radar reflectivity, and near the end of the loop, go ahead and make that move forward here, near the end of the loop we see that storm is dissipating. And one of the questions you may ask here is we see that dissipation occurring soon after we see some of these mid-level stratus clouds. Are these correlated with each other? Is this coincidence? It's hard to say. It's one of those open-ended questions. So one of the things to take away from this here is you're seeing things that you just wouldn't have been able to see in the 15-minute imagery when you're looking at this very high temporal resolution imagery. So at times you'll see things that make clear sense to you in terms of what's going on with the storm. At other times you'll have some open-ended questions that will be presented to you, and that's a good thing. We'll just learn more and more as we continue to look at this 1 minute imagery. Let's move on to the next time period, and we'll start off with the storm we had been talking about near Cheyenne, Wyoming. And you can see that it moved towards the southwest, actually went through a brief reinvigoration, I'll call it, just before it completely went away. And likely what happened with that storm as it moved further to the west did move over some higher terrain to some elevations up around 7,500 feet. And then it moved east again, perhaps moving back into its own outflow and dissipating the storm. Meanwhile, you see additional convection further to the north in Wyoming. But what we're going to really focus in on is what was happening down here in Colorado. We see three areas of active convection. Over the Palmer Divide, we see multiple storms decaying and leaving outflow boundaries for new storms. And by the end of the loop, it looks like the convection has consolidated into one primary updraft that we see in this region with a more pronounced overshooting top. Another area to look at is over the northeastern plains in this general vicinity, which doesn't look as robust as the convection we had just mentioned down here. And then finally, further northwest near Denver, in this region, we see an additional area of convection, perhaps along an outflow from the earlier storms. Keep in mind, still no tornado reports through this time period. And finally, remember the line of cumulus that we had been following here. By the time we get to the end of the loop, we can see it start to get some towering cumulus as it's approaching the Front Range. In other words, it's moving upwards in elevation here. So we're going to keep an eye on that as we move to the next time period. We move forward to the last time period, and we first focus on the Palmer Divide convection down here. And we can see that this particular storm now looks much more intense, with a well-defined overshooting top, an enhanced V that comes out something like so. And the storm has taken more of a turn to the right. Looks like it's moving more to the southeast than it was earlier. On the western flank of the storm, it appears that we have invigorated cumulus above an RFD, which is a sign that the storm is undergoing intensification or near its peak intensity. And then on the southern flank of the storm, we can see this line. Go ahead and draw it in right here. That appears to be intersecting the main updraft here. So we may have this boundary intersecting with this storm. So I'll go ahead and let that loop, and you can clearly see that line moving into the main updraft here, with the western edge of that line bent back to the north into the inflow region of that storm. Multiple tornado reports are associated with this storm, along with very large hail up to baseball size. Meanwhile, north of Denver, the line of cumulus that we had been following, I'm going to stop the loop and highlight that line of cumulus right here along the Front Range north of Denver, now begins to get some towering cumulus with it. And it just continues to grow. So now storms are developing along this line that we had been following. Meanwhile, remember that convection we had been following further to the south is continuing to slowly move to the north. It looks like at times new storms going up along outflow boundaries from some weakening convection. But we continue to advance along and stop it a little bit later in the loop here. And what happens is actually pretty interesting here. We get looks like a few different updrafts along that region further to the north, and then we have a storm in the vicinity of Boulder down here. That southernmost storm continues moving to the north. It looks like it lays down an outflow boundary. We go to the next image, an outflow boundary just north of that storm, and we get a new tower right here. And then notice that we have on the southern end a pretty vigorous looking storm right here with this overshooting top. Continue to advance along here, and it looks like what happens soon after that is we have an intersection likely between the southern end of the storms that we had been following and the northern end of the outflow of the other storms that had been coming up from the north. And right where those intersected, we get really enhanced overshooting tops here by the end of this loop. And in that particular area, there was a tornado reported along with ag-size hail. So a number of interesting things that you can see here in the 1-minute imagery, and information that you can make use of not only in terms of how the near-storm environment is evolving here, but also during the warning decision-making process, how these various boundaries are interacting. You can quite rapidly see how these new overshooting tops go up. And remember, when GOES-R comes along, we get that 1-minute imagery, you're going to have this imagery on your AWIPS in about 1 minute, which will enable you to actually use it during the warning decision-making time period.